Now I want to tell you what are the results which are required to solve the problems of the integration. In fact, all results which we have used in differentiation will be used here for integration, that is the antiderivative. How it will use, that I am telling you. We know that the first result is that derivative of x to the power n is what? Nx n minus 1. If this n is transferred here, then the derivative of x to the power n upon n is what? X to the power n minus 1. If any constant is also taken, then derivative of x to the power n upon n plus constant is also what? X to the power n minus 1. Now we know that if differentiation of gx is fx, then integration of fx is gx. So what conclusion is coming? That the integration of x to the power n minus 1 is what? X to the power n upon n plus c. But if I want to generalize this formula, so in place of n minus 1, I put n plus 1 both sides. So first and very important result, that is integration of x to the power n. I am putting n plus 1 in place of n here. So as I replaced in the left, I need to replace in the right side. So this become n plus 1 x to the power n plus 1 upon n plus 1 plus constant. This is the first result which will be used to solve the problems of the type having x to the power something. For example, if I ask you what is the integration of x to the power 4, you will say using this result n can be replaced by 4. So answer will be x to the power n plus 1, that is 5, upon n plus 1, that is 5, plus some constant, any constant, maybe c, k, l, p, q, r. This is also applicable if this power is negative. Suppose power is minus 3 dx. So it will be x to the power minus 2 upon minus 2 plus some constant c. The same is also applicable for the fractional parts. The fractional part, that is fractional power. So what will be that formula in case if the powers are in the fraction? Suppose you want to find the antiderivative of x to the power half. It will be x to the power half plus 1 upon half plus 1 plus c. So integration of x to the power half dx stands as x to the power 3 by 2 upon 3 by 2 plus c. So this becomes 2x to the power 3 by 2 upon 3 plus some constant by using the formula x to the power n dx, that is integration of x to the power n dx is x to the power n plus 1 upon n plus 1 plus integrating constant, always used for the indefinite integral is c. So with the help of this, I told you the integration of x to the power 4 is x to the power 5 upon 5 plus c, x to the power minus 3 is x to the power minus 2 upon 2 minus 2 plus c, and x to the power half integration is x to the power 3 by 2 multiplied by 2 upon 3 plus c. So this is the way which by use the result x to the power n dx is equals to x to the power n plus 1 upon n plus 1 plus c. Now in the list of continuation of the results of the integration, I am going to tell you that we know that when we do the differentiation of log x under the base e, we get to know it is what? 1 upon x. We also know that the derivative of log x base e is 1 upon x along with some constant, suppose c, it gives us 1 upon x plus 0. So we can say 1 upon x plus 0 is again 1 upon x, and now with the help of these two, what we can conclude? We can say the integration of 1 upon x dx. Integration of this or integration of this, we can say either log x e or log x e plus c. We always take the constant, integrating constant. So we will write that the integration of 1 upon x dx is log of x e plus integrating constant c. Now I am taking the next result. We know that the derivative of e to the power x. Third result is that the derivative of e to the power x, the derivative of e to the power x plus some constant d upon dx of e to the power x plus some constant is what? E to the power x plus 0, or we can say only e to the power x. So antiderivative of e to the power x is e to the power x plus any constant c or k, whatever you want to write. Now the question raised that if in place of this x there is something, that is it is like e to the power 2x dx, then what will be the answer? It will be e to the power 2x upon 2 plus c. That constant has to come here. So we should know that e to the power kx, e to the power kx dx, its integration is e to the power kx upon k plus c. So ordinary we can apply this, and if it is x with some number, then it will come like this. Next result, that is the fourth one. As we know that derivative of, the fourth result is the derivative of a to the power x. We know that its derivative is a to the power x log a e. But if it is with some constant, again I am telling you it is a to the power x plus c, its answer is a to the power x log of a base e. Now the integration of this part, you want to know what is the integration of a to the power x. So before it I want to relieve the log a e in the left side. So it will be derivative of a to the power x upon log a e plus c is what? A is to power x. So what we can conclude, that integration of a to the power x is equal to, a to the power x integration is this, a to the power x upon log a e plus c. So this is the fourth result, very important result, which will be used while we will solve the problems of the integration. Now I want to discuss with you the next result, that is the trigonometric integration of sin x. What is the integration of sin x? It is minus cos x plus c, because the differentiation of cos x is minus sin x. So this sign is transferred, and always we need to take what? The constant. Then we can take the sixth result, that is what is the integration of cos x? The integration of cos x is sin x plus c. Next we can say what is the integration of tan x. If you want to know that what is the integration of the tan x, we must know of what number the differentiation is the tan x. So we need to trace that. If I ask you what is the derivative of log of mod of sin x, you will say log of mod of sin x, its derivative will be what? Cot x, because log of sin x will go down denominator, and derivative of sin x will come as the cos x, so cos upon sin cot. Now the derivative of log of mod of cos x, what will be this? It will be minus of tan x. So the result will be derivative of tan x from here will be minus of log of mod of cos of x, and by this we can say integration of cot x dx is equals to log of mod of sin x plus integrating constant c in both the results. Now integration of sec x. If we discuss about the integration of sec x, we need to think for such a function whose differentiation is sec x, and that is log of mod of sec x plus tan x plus integrating constant c, because the derivative of this will be sec x, hence antiderivative of sec x is this. Similarly, integration of cosec x. Integration of cosec x is log of mod of cosec x minus cot x plus integrating constant c. Now, you know that when you differentiate tan x, we get a sec square x. So, from this what we can conclude? We can conclude that the integration of sec square x, is what? Tan x plus constant c. Similarly, integration of cosec square x dx is minus cot x plus c, because derivative of this part is cosec square x. Next, integration of, we know that the derivative of sec x tan x. The derivative of sec x is sec x into tan x. So, what we can say? The antiderivative of sec x tan x. The integration of sec x into tan x dx is sec x plus c. Next, integration of cosec x into cot x, it is minus cosec x plus c. So, these are the results, direct results, and now I want to discuss with you the results which are to be used in the inverse. As you know that the differentiation of sin inverse x, we know that the derivative of sin inverse x plus c is 1 upon root of 1 minus x square. So, what we can say? The antiderivative of this, integration of 1 upon root of 1 minus x square dx is what? Sin inverse x plus c. So, there are few results which are based on the inverse formula, which I am telling you now, starting with the continuation of the 15th result, that is the integration of 1 upon root of a square minus x square dx. If in place of 1 I write a, so this will be sin inverse of x upon a plus c. The next is integration of 1 upon a square plus x square dx. You know that the derivative of tan inverse x is 1 upon 1 plus x square. So, that is why in place of 1, if a is being put, then the formula of 1 upon a square plus x square is 1 upon a tan inverse. It is 1 upon a tan inverse of x upon a plus c. Now, integration of, that is, we know that the derivative of sec inverse x. Sec inverse x derivative is given by 1 upon mod x root of 1 minus x square minus 1. This is the derivative of sec inverse x, 1 upon mod x root of x square minus 1. So, if we apply the formula of the antiderivative in this result will come that 1 upon x into integration of 1 upon x into root of x square minus a square dx. It is the result 1 upon a sec inverse of x upon a. 1 upon a sec inverse of x upon a plus c. So, these are the results which are required to solve the problems for our topic so called indefinite integral. As and when indefinite integral comes, these values, these results, these relations are required to learn, required to understand, then only in the problems we can apply and solve the formula.